from experience, I guess, working or trying to work with both. Let me, I guess, give you a kind of a quick structure as to the quality of different tools. Now, naturally, everybody here probably heard of SAS and SPSS and MATLAB, and now these are the known giants that predate history in, I guess, in statistics or using computers to run statistics, right? SPSS and SAS and have been around for some time. But let's put this in perspective. These guys are private companies made for profit right now. And understandable, there's nothing wrong with that. But to a lot of companies, $50,000 per user per year is a significant amount of money, right? So that's why there is a significant tilt or shift into open source. But there is also other key factors that go into that. And that is, in R, for example, there is a massive foundation that manages R. It's who's who in science and technology and research labs and universities and so on that have come together, and they put some rules and regulations around the standards that need to. So in R, for example, there is probably 13,000 libraries available in almost every domain you can think of. Science, technology, economics, anything you think of, there are libraries for that. And it goes through a significant vetting process when a library is accepted into the CRAN. And that's the foundation that manages R, the R project. So when a tool is supported by CRAN, or it's available, and because it's also open source, it gets a significant amount of vetting to the quality of what it is and what it does. And now there may or may not be, for example, a vignette, how to, or examples, maybe significant amount of examples that use a particular package. But at least there is a certain mandatory, I guess, compliance that need to be enforced, and it is. Now let's compare that to, say, SPSS. So SPSS or SAS, they release a new version. How many people outside of SAS would have actually any vetting into whether an algorithm works or not? Do you know any?
Companies do it themselves.
They do it themselves. How many people inside the company actually do that? A significant formula and an algorithm, and especially now with releases, let's say like TensorFlow, and so naturally TensorFlow is an open source now, but if it was, let's say, a SAS or an IBM product, SPSS, how many people would get a chance to actually look at what's inside it and how it works? Would IBM or SAS dare to share? Maybe? No. Okay. It's proprietary, and understandable it's proprietary, but at the same time, in terms of its performance to the task, who guards that quality control? It's internal to them. So if they decide to do whatever they want within that algorithm, you don't know, right? And they will not tell you, because that's their trade secret. rightfully so. But in terms of quality of what it delivers, we kind of have to question, is this at the same level? So I leave that to your judgment. Now let's parlay that into Python. How about Python? See, one of the challenges, and that's why I want to relate this to you yesterday, because we had on the old platform, which we had to kind of shut down on and off the last couple of weeks for some technical problems related to security. We had some of these scripts running on that environment, and as we were updating them, and there was both Python 2 and Python 3 running, and we brought that over to this platform, which is limited to Python 3, but it's not even maybe the same versions of libraries that were updated or not updated. And we ran into a significant amount of time yesterday trying to get some of them. It's like suddenly they all don't work. And I started swearing, actually. God, what the hell is going on? Why don't they work? And it kind of, I remember, this is one of the problems that we often encounter with Python. Not that it doesn't, it's a fantastic language, but the problem is that it's like a loose net of people making changes, putting them out there. There is a loose governance. So if you just happen to copy a script, even from a professor, known professor, and you run it, it may not run exactly the way it's written, and you have to probably think about how and do some research in order to do that. In R, yes, you still have that same problem, but at least there are some guidance and governance and so on to that. In Python, it's really loose net, and we have a couple of Python experts that we often call on, and they come in and they know, they've done some of the work, and they kind of know how to resolve some of these problems. So just because there is a script out there that somebody had written, okay, the versions of the libraries may be different, the syntax may be different, and a whole lot of things are different. You've seen even that in some of the things. We left some of that with the idea of sharing that with you, because it could get you in trouble. Now, again, I am not trying to convert you. If you're comfortable working with the language you're comfortable in, God bless. No, you get no objection as long as you're able to produce and you're not getting frustrated. Okay, so with that, basically, let me then segue into this. Now, one of the things that we do in what you've seen today, actually, we do this in preparation to. We do that before we get people into the boot camp. But I wanted to gauge from you. Did you find this to be new to you? Did you know it? Or was it boring? Just kind of some feedback.
And some of it was new, like learning stuff on functions, methods, modules, forks there.
Yeah. Okay. Anybody else? Yeah.
I would agree. The little bit of training like that only resolve into basic stuff instead of getting into the lighter topics. Those would be good.
Yeah. There is a lot of material that is basic, really basic out there, and yeah, you have.
No, for myself, I just need to be pointed in the right direction. Some of these things I don't need to do hands-on today. I just show me where to go and I'm good. So I like this.
Yeah.
Okay. I don't know what I don't know. And that's why I'm here. And so I think that's just right.
Yeah, we plan on continuing some of these in select areas, at least over the next while. Naturally, the problem is that a lot of times is availability of people, calendars, and also the venue. So if you happen to, at your company, or you know of a place where we can, because this place is not cheap and it's not always available. I mean, I booked this place 2 months ahead of time in order to make sure that I have it. So, and in addition, of course, it's not cheap.
If I may add,
So,
my own motivations. I started with R because I wanted to have something where I didn't have to look under the hood in terms of the software and the coding, but methods that work quickly and where I could focus on the data science aspect. How do I work through a data project from start to finish? But I knew I needed a Python component to be competitive in the marketplace. That's why I'm adding that quickly to myself, because a lot of the stuff like Spark with PySpark, these big data analytics tools are built upon Python, and most of the industry out there is also strongly driven. Python is driven by the engineering science community. That's where a lot of the folks come from who are breaking into data science. They're used to Python. R is mostly driven by the biostatisticians, statistics community. That's also why the philosophy is a little bit different. Python sometimes appears a little bit like a hodgepodge. I mean, I'm not a software developer, but I hear that also from people who are more of the experts. You have to piece things together a little bit more. It's not a major thing, but you have a little bit more familiarity with, for example, this object-oriented aspect. You don't worry much about that in R. In Python, you have that more flexibility. So that's what I like about my training, because now I can go to Python and resources is tricky. And doing an online course is also tricky because you don't get that much exposure. A lot of them don't have a mentoring component. And even if there is, then it's oversubscribed because you have 1,000 users talking to a select few folks who answer the general questions everybody has. So it's a little bit up to taste. Also for the boot camp, I think Frank wants to have about at least 10 to 15 people to make it work. And when we did it in the fall, we had about 11 or 12 people, off and on, a core of 10, but about 12 who kind of showed up off and on. And that kind of worked. And so the more people he can gain for boot camp, the better you can make it work. And anyway, that's just my plug to the boot camp.
Yeah. Before we get into the boot camp itself, just to give you a lay of the land of what's going on in the industry and in business today. A lot of people basically have done a lot of this in terms of the historical data and even in the big data, collect everything, we're talking about that. But basically this is where a lot of companies are in that space almost, depending on the industry. Some haven't even gone deep enough in the ad hoc reporting, dashboards, data warehousing. But also this is where there is a significant change in culture, and in that data warehousing, for example, is seeing the biggest change in two areas. One is the fact that a lot of the traditional data warehousing are beginning to hit that kind of ceiling in terms of their capabilities at handling more massive amounts of data, and also in terms of costs. The costs are beginning to change dramatically because a lot of these powerful, or so thought of 10, 15 years ago, have reached their maximum in terms of what they can do in technology. So there is, with big data, really big data is a replacement, is kind of a data warehouse. The new data warehouse today is not the traditional Teradata and others, Netezza and so on, but it really is the big data. Big data is taking that space because they are a lot more massively capable at expanding. Okay, it's cost effective because you can throw in new nodes and new servers without without having to do any shutting down of operations. You can literally add in servers and they will connect and start immediately chucking along and produce results. However, the biggest gap right now in, beyond that is that, okay, so now we have this more massive data, and also in addition to the structured data, now we have unstructured data, which throws in a new challenge. And that challenge is that in structured data, okay, you can grab that table or join a couple of tables or 10 tables and maybe produce insight. Maybe, I say maybe. I'll address that in a second. But then also, what the heck do you do with unstructured data? How many of you have seen server logs? What do they look like? Anything structured?
Yes.
Tables?
Nope.
Is there even an order to them? No. It's ad hoc. Ad hoc records. That's basically what you have, is ad hoc single records. That's what you have. Okay. It's a hodgepodge, and the challenge is that how do you align that? How do you synchronize that? Even if it was the same data, but a whole different sequences of timestamps. It takes significant knowledge and expertise even to take a time series that are collected from everywhere and kind of align them and synchronize them in a manner that you can then produce some insight in terms of understanding anomalies, for example, for performance, or maybe for attacks, or maybe for anything else, maintenance and so on. We were talking about manufacturing. A lot of the sensory data, for example, it's coming from different sources into different files, different timestamps, and the challenge is that do you have that expertise and knowledge to be able to align it properly and be able to draw some significant value proposition to be able to say, this is what we can find, and it's costing our production this amount of money because of this. We can fix this. In order to draw these conclusions, you really need that advanced knowledge. And that's where, that's a significant amount of expertise that is needed right now. And yes, you can look at some of these fantastic material, okay? But what you are taught is pieces of a puzzle, but you don't know how that puzzle fits. In fact, some of our students, this was their comment. We had that great, I learned how to do this and that, and even further down the line and so on, and then, okay, now I know everything about this. Okay, and then what do I do now? And then they go in another direction and they learn about this and this algorithm and, oh, okay, what now? Their biggest challenge is that how do we put all of these pieces together, and when? If you have a business problem that you need to solve, it's not so much that you already know the central limit theorem and you know a particular algorithm. It's that what do you do and at what stage and what can you expect? What's the outcome that you should be getting realistically at that point in order to move forward? So the methodology is not there yet. The skill set is that, yes, universities will teach you, central limit theorem. But how does that relate to an executive who's going to give you $1 million to build a solution for him? What does he care about the central limit theorem? Why should he care? So the challenge is to interpret that, to be able to interpret that to the business person, to the operator, to the technician, to the director, to that multilingual talent. So it's not so much of all of this, but the idea that
use the left
in
lane to turn left
the
onto
data
Mayfarm
science,
Road northeast.
you have
Then your destination will
significant
be on the left.
number of skills that need to be there. Now, how many of you know one person that is an expert in all of these? Yet, companies go and look for that data scientist, that magician, shaman, predictor, master communicator. How many of you know a fantastic mathematician, a supreme mathematician that is a good communicator? Really? Really? My partner and his team couldn't sell their shoes if their life depended on it.
This stays internal, of course.
So the idea that a company is going to hire that right out of an Ivy League, MIT and Georgia Tech and so on, and somehow that magician is going to solve all of these problems for them. Really? Where? You see, that's the challenge, that what is needed is a team. A team not just of experts in these specific areas, okay, but they need to start coming together and learn how to do it, how to take raw data and who needs to do what, and at what stage, in order to produce the results. So basically, here's the other challenge, is the culture. We're talking about culture, right? A lot of companies think, oh, well, hey, look, this is programming. Python is programming, right? Yeah, and R, what is R? We don't know that. Let's chuck that, let's just tuck it in under IT. A lot of companies make mistake. Tools, skills, methodologies are not the same. Even if we take a set of tools for data science, we give them to IT to manage, they have no idea what they are, and they have no expertise. And it isn't their domain just because they are built on Ubuntu servers and others. That's all they have in common. Apache and Ubuntu server. There are no less than 20 different softwares that we deploy on our own platform, let alone probably, if you were to think of the SAS or SPSS and so on, they are probably, who knows. But these are tools that IT has never deployed anywhere. So how could they actually manage that? How could they actually know how to put together a team? How many of you, or how many do you know that successfully interviews data scientists? A lot of people are basically tasked with, okay, Joe, you are a good, loyal director. It's difficult. It's a challenge. Okay. More to the point, data products are unique skills, technologies, and methodologies. How does he know how to put together a team? If he can't successfully interview a data scientist, apart from counting on his buddy at the local university, or maybe at an Ivy League recommended by some friend of his, how would he know? Now, data science impacts revenue in a massive, massive way. It cannot be, now we say this, it cannot be tucked under IT. But that's also a cultural change that need to happen. Okay, so now what? Here's the other challenge. Okay, so all these companies, basically what they have is a whole lot of systems that serve their purpose, and they put in big data. Now what they need is to put this in place, the team that delivers this, which then feeds back into their CRM, their case management, their ERP, their manufacturing, their whatever tools that they are using, feed the results of the models into these solutions. An example, let's say we're talking about marketing analytics. So for marketing analytics, the source system is the CRM here. The source of the data, mainly CRM, web logs, purchase data, social media, etc., etc. And now the data comes into the data science team. In other words, once it parted away from IT, it has no connection anymore in here into IT. All the work needs to be done by the data science team. Maybe they may have some programmers, architects, etc. working here, but there's no actual structural connection with the data anymore until models are built and fed back into a CRM. So the results of the predictions of identifying, let's say, targets for approach with a new product or retention and other target marketing, it gets fed back into the data. All IT has to do now is, what do they do with that data field that got added into the database? So all they have to do is create a widget that says, this guy is going to bail out from AT&T, or from Cox, or from whatever the company is. They are going to switch to the competition. So the prediction now is not about past data, historical data. It's about what's going to happen in the future. I am going to bail out on AT&T, and I'm going to T-Mobile. The ability to predict that is what's revenue impacting, because it costs AT&T $500 to acquire a client. Now, to switch from AT&T to T-Mobile, okay, that's a loss of $500. Just to replace that, right? In business decision making, you have to replace that. Otherwise, you're losing market share. So to replace that, you have to spend the $500 to acquire that new client. Okay. Now, if you were to go to me before I switch and give me an offer that is worth $100, the model that Mark built for them will predict that I would accept $100 offer, and I'd accept to stay. So what did they do? They basically prevented a loss of $400, and it cost them $100. So that's a significant revenue impact. Okay. Now, even if they are charging me, even if my bill is $100 a month, that's like 5 months, right? So these are the decisions that businesses need to know. So how do we do this? This is what our training and platform is built to do, to solve this, basically. How do you take this? What do you do with it? How, when, why, etc., and then feed it back into here. A lot of companies, basically, they have this as a challenge. You know, even some of you may have built models. How many built actual models? 2, 3. How did you deploy them? How did you put them in production? You didn't.
SAS.
SAS. Okay, yeah. How did you put it in production? You have no idea.
No.
Right. How do you put it?
I put some in production with SAS and others were hard-coded into applications that the customer had.
And the application was written in what language?
I don't know what it was. I left it up to them. So I did the stats
Okay.
and they did the...
Now, let's take this. Let's look at this. Regression is simple to take and code into other languages. But let us suppose, not Home Depot, let us suppose for a moment that a store has 300 items only on their shelves. They only sell 300, not Home Depot. Okay? Now, to build a market basket analysis, and that's an association. What kind of association exists between product A and product B? Milk and beer. What's the association between milk and beer? The set of rules that are produced as a result of a good market basket analysis are about 80,000, north of 80,000. Okay? Now, how much time does it take somebody to code that into an application? How much, not just how much time, how complex it is actually to test and maintain and put in production.
It's very tricky because normally that programmer doesn't understand what it's doing.
Right.
So,
Let alone, now in SAS, yes, you're not moving it out of a language into another language. You're maintaining it in the same language, but at the same time, the cost, the overall cost of SAS is not cheap. Now, in our platform, for example, and there may be others like it, it gets built in R, it stays in R. It's just deployed in R into an API with an API call. Any application here, any application, all they have to do is know how to call that API. Frank Hasbani, age 63, married, no children, credit score 760, debt service, or let's say 20%, etc., etc. Do we lend him money or not?
no.
No, exactly. So all the programmer or the developer has to know is the string to send, predict arguments, Frank Hasbani, or some code, age, etc., age equal, and so on, credit score equal, It's just one string, one call. He doesn't have to know how the model works. He doesn't need to. The model doesn't have to be tested because it was already tested. It's gone through that process of that vigor of testing, cross-validation, and it's been accepted. Even the results, the confusion matrix, and other performance statistics about that model has been accepted and tested. Okay, so now what happened then basically is it's very easy, very simple to deploy. But the challenge is still for any of you or your company is really how do you put this together? Okay. That's where our R bootcamp and Python bootcamp and a series of not just introductory and intermediate and more advanced. We have also, we're building in association with Georgia State University a series of these topical, where, let's say natural language processing, time series forecasting, machine learning, and so on. Very specific that you and your company can take advantage of in order to build the team. Now, how many of you are currently in a position that is kind of geared to or part of a team to data science? Okay. How many would hope to get in to that? Yeah. And it really is, yes, I know, I read all the articles and the sexy job, etc. You know, it sounds great, but the reality is that you need to learn enough skills. Let's go back to that chart. You need to equip yourself with some specialty within that area. And it may be already something that you already have, you just need to build it up in terms of data. The other big challenge is that I worked for about 3.5 years at AT&T. What I was doing is, I was a program manager. What I was doing actually was designing the data that needed to go in the front end. At what point, when, why, under what circumstances does a particular record with particular set of values in these variables get fed into the logs? In other words, the data doesn't just appear out of nowhere just because you have an application on the web or some sort of a solution in IT. The solution that was built by IT, like CRM, for example, was designed for functional purposes to solve a problem of automating the sales process. It was not designed to tell me the sentiments or the inclinations or maybe the geographic, but not the demographic makeup of these clients, their buying habits, etc. It was not designed for that. So in order to do that, there is a massive need for that kind of work. The right data need to feed in, not just any data. The cleaning, the skills that are required for cleaning, where do you put it, from where to where, how do you manage it, how do you stream it, does it need to be streamed, or does it sit at rest, and so on. Visualization, demonstrating trends, and is not just learning how to use Tableau. Tableau is a great tool. But if you don't know how to interpret these trends to the business people, all it is just a pretty looking colors. And you may be graphically inclined to make the colors kind of fit together. It still doesn't tell the executive anything. You need to interpret it in business language and so on. And the same thing with patterns and machine learning and artificial intelligence and all these domains. Okay. So where exactly do you see yourself fit on this is what you need to focus on. You can't just go at ad hoc. One of the things that we found out about the boot camp by kind of coincidence is that we were able to identify where the strength and weakness of each person through the exercises that we asked them to do and the homework and the projects that they did, where their area of expertise lies. And that is massive. That is extremely valuable because now a company can figure out your company, where exactly do you fit in this? And they will be able to figure out where their gaps are. So then they can at least have an understanding, a conceptual understanding of what they need to put together in order to build that team and get you to work together. How long did it take you to produce a model?
Some models were a couple weeks, some were months.
Yeah,
So produce it, then you gotta write about it.
explain
All
it.
the due diligence. And
Right, how many are you in the team?
that team, I'm thinking of this, there were two of us.
Yep. Bill?
The one I'm thinking of was pretty fast. Data scraped from the website, all built in 2 or 3 hours. A day to organize it and produce it and explain it. And that stuff.
I have a lot of regulatory.
What do you mean?
I have a lot, I'm a bank, there's a lot of regulatory.
Ah,
You can't-
right,
you can't just-
okay, okay.
You gotta be careful with
Yep.
the codes. And
Yeah, I often actually look at your analysis.
Well,
I love the stuff
there's,
that-
there's
that
regulatory
comes
stuff and we have marketing, right? So
Yep.
there's two different things going on, so depending on which one you're,
Sure,
which world you're in.
yeah, but you're starting with good data naturally, right?
No. That's why it takes months.
You would think so.
Right,
You think it's good and then you find out, oh no, it's not.
it's not.
Yeah,
When do you find out?
after you run the model. No, you try to figure that out beforehand.
Yeah,
And you talk to, I think that's the most important thing, is you have to understand the business. If you're going to be a data scientist, you have to understand the
subject
business.
matter expertise. You see, a lot of times, yeah, in small projects, you may be able to do all, or a couple of people may be able to do in a small domain kind of, okay, in a small scope. But where it gets really very complex, you can't. Just too large and difficult to manage and deliver. Okay. We had somebody a couple of weeks ago with Black Book. It took them a year to build the model for pricing cars.
Doesn't seem that hard. Doesn't seem like it should be that hard.
No, but you don't know that. You wouldn't know that, right? How about you?
How long?
How long?
Months. Starting from scratch.
Yeah.
Defining your data sources, learning the correct data sources, redefining your data sources, cleaning, modeling.
60% of the time actually is really spent in the pre-modeling. 60 to 80% of the time. Running that model or algorithm is just a matter of power. Now, once you know what algorithms you're going to apply. The last thing I want to mention on this in terms of what the boot camps are is that not just you learn how to and what to do and so on, but we only get you started on your learning. But what we do for you is that you will learn where to find the information and how do you learn about it. Because you need to put yourself on a path of learning for probably the next 3, 4, 5 years and more. That's what it takes to become a good practitioner. Doesn't matter which area or a couple of areas that your strength is. Okay? But you need to put yourself on that path. And in order to do that, you need to find the resources and also understand the pitfalls. Because as we were saying earlier, you can copy a script from somebody that ran something that seemed to be, hey, it solved a similar problem to yours. Just taking that and trying to could end up being very frustrating. So the things that we help you understand is that the tools are almost hardcore tools that you will need in each step to do, and how to find the information, how to learn about that library or set of libraries, and where to find that. And more than anything else, when you run something what's the outcome? How is the outcome an acceptable value, or is an acceptable outcome that will then help you move forward, or do you have to go back and redo the work that you did, right? And that's why a lot of times we start over again. You have to start over. And that is also significant because this is one of the methodologies that we do teach you, is that step-by-step process. These screens sometimes are confusing. Yeah, now this is a kind of a generic process, but really in terms of the complexities. So, for example, this is just a number of areas of knowledge that we can help you get there. It depends what area it is and so on. So as we develop these in conjunction with, like for example, we have one coming up soon, is the natural language and text processing. We have a preview of that actually next week on Wednesday, here at night in the evening, and it is on the same meetup site that you did RSVP for this. So come and take a look. Dr. Molnar will talk briefly about that, the natural language processing. We've developed some of these already, and some are underway. Because what we need to do is that we need to make sure that you can take that and apply it. What we teach you is very practical, very business-oriented, and what do you do with it? It's not, like Mark was saying, we don't teach you the statistics, and this isn't what we do. This isn't our expertise. The reference is probably one of the best in the business that Mark gave you. We don't teach you that. It's theirs. Now, but let me explain a quick difference. One of the models, actually, I ran to it because I'm interested in the stock market. I studied finance way back, and I was a financial planner. I took a hiatus from IT, and then I went back into IT. During that time, I became knowledgeable in the stock market, so this was special interest. I took the script that they had about the stock market. Now, the accuracy or the win versus lose prediction was 50.04 in one case and 50.06 in another case. It's like, I would flip a coin and just be as accurate. To predict, in other words, to predict above 50%, you see, it's that simple. Flipping a coin is a way to predict.
But if you're Warren Buffett and have enough money, that 0.04% might be exactly what you need.
They showed that you can use a time series. That's what they were showing. They were not teaching you how to try and predict the market. It's just they are teaching you the concept. Great. And you learn the concept there. But how do you take that and actually apply it in real business? I managed over 80 projects in analytics. At at AT&T, the weather company, Corning Inc., US Bank, and other companies. So I can teach you. We can, our team, you saw that earlier. Our back office is the 800-pound gorilla. They have 20 years experience, so we can show you. Okay.